Okay, well, I am just too excited to wait, so we're going to go ahead and get this started. I want to say good morning, good afternoon, and good evening, depending on where in the world you are. I'm Monique Sherman, Head of Marketing at Automation Hero. I'm really looking forward to this discussion as we have a very timely and important topic to cover. Today, we're going to be discussing AI governance and how businesses can prepare and protect themselves in the wake of new AI regulations. We have joining with us today, GigaOm analyst Andrew Brust. Thank you so much. And our founder and CEO, Stefan Groschupf. Before I hand it over to them, I want to call out a few housekeeping items that won't take too much time. I just want to let you know that this session is being recorded and everyone will receive a link to the recording after this event. If you have any questions, please feel free to use the chat or the Q&A option at the bottom of your screen. There is a Q&A session at the end and we'll get to those. And if anything that we can't cover, we will follow up with you guys directly. I don't want to take up too much more time, so I'm going to pass it over to Stefan and let him do a quick introduction and then over to Andrew. We're looking forward to sharing our insights and hearing what you guys have to say as well. Take it away, Stefan.
Thank you so much, Monique. Really appreciate it. Hello, everybody. Thank you so much for joining us in the season. We're really appreciating you guys, you folks, taking the time today. This isn't the most exciting topic on the surface, but I think it is an incredible, important topic that will impact everybody that is very serious about AI and automation. So thanks for joining. I'm Stefan. I'm the founder here at Automation Hero. And I started I built my first machine learning model actually in 1997. And people said, I'm crazy. I saw too many science fiction movies. It only took 25 years for people to come and see the phenomenal opportunity here. Between that and now, I co-founded a technology called Hadoop, started a company called Datamere. We processed 80% of our financial transactions, and now since a little bit over 5 years, we working at Automation Hero, making it really easy to build intelligent automations with a lot of deep learning capabilities around unstructured data. And we're really excited to tell you about some of the new stuff we're working on, again, given that there's now external regulatory pressure to do this. So I'm very honored and excited to also welcome and introduce you guys to my good friend, Andrew Brust, who is just one of the most brilliant analysts out there, doing this also for a long time. But Andrew, I let you introduce yourself and share your background. And you're on mute.
Andrew, did we lose you?
No, and Andrew switching the microphones. Meanwhile, Andrew lives in the beautiful New York City since many years.
Am I coming through now?
Now you're coming through. Andrew.
Okay. Yeah, I wasn't on mute, but my headset went kablooey. Forgive me. Luckily, I had a spare at the ready. So besides the fact that I'm not a hardware guy, which apparently is now clear, I have a very mixed background. For a long time, I was a developer and a database guy. I had a small consulting firm. I sold it to a slightly larger consulting firm and helped run that. You mentioned you built your first machine learning model in the 90s. I guess we weren't calling it machine learning then, but I was looking at AI and languages like Lisp and Prolog in the 80s and was excited about what we were calling AI then. But, it wasn't even science fiction. It was like science fantasy. So to see things get to where they are now, is gratifying, certainly. And what I've been doing for the last decade plus is I've been a tech journalist, tech industry journalist and a tech industry analyst. I guess applying my experience seeing lots of product and technology cycles before, and sometimes griping about how we're making mistakes in the industry and how we're doing good things and how some of these movies we've seen before, and that all kind of combines to bring me into this. And I've also worked on the vendor side. You and I have some collegial history, so I've tried to see everything from all the different angles.
Andrew, you will help us today to understand a little bit more about life cycles with machine learning. But folks, if you, to reiterate what Monique said, if you have any questions, please put them in the chat, or you can also send us an email and we will monitor that during the webinar. Our goal here is really to help you to understand. So please feel free to send as many questions as you want. So with that, Andrew, why don't you walk us a little bit through, given you we are also the author of the GigaOm machine learning operations radar, and basically saw everything that is out there. Walk us through the workflow and the challenges that companies typically see there.
Sure. And yeah, we have now a recurring radar report in this category, as well as an accompanying key criteria report where we focus less on the vendors and more just on the the rigors of what it's all about. So this came from the original key criteria report. I would direct everyone to that rectangle that says data ingest on the top, just to the right of center. That's kind of where things start. And this has basically been the machine learning model for quite a while. In the age of generative AI, it changes a little, but not all that much. There's obviously, before you do much of anything, you've got to bring your data in. That's what the ingest is about. And, typically it's unknown unknowns. So before you start applying things and building a model, you've really got to look at the data and understand the contours of it and the profile of the data, and not to mention the quality of the data. So that's what the data exploration is all about. In machine learning models, we have kind of inputs that we call features and an output that we call the label. But you don't know in advance which columns in your data set are going to be candidates for features. Typically, they're not candidates directly anyway. You've got to do some engineering around them. So you've got to pick your features. You have to do a good deal of data transformation to get them to be really feature ready for the model. Once you've done that, it's time to train your model, but typically that's not one and done. You're going to be training multiple times with different features and with different algorithms until you get a model that has the right amount of accuracy, an acceptable amount of accuracy. That's also what the testing is for. Once you've gone through various iterations of training and testing and training and testing, finally, and I think this is going to be a big focus of the discussion, it's time to deploy the model. Now, that's not something you want to do casually, let's just say. In the salad days, in the early days, the scrappy pioneering days of machine learning, maybe we went ahead and deployed right away. That is just simply not something we can do in the current regulatory environment. And it's not just that there's regulations, like it's not the fault of regulations. The regulations are there because this isn't just a science project on the side anymore. This is what companies are doing to run an increasing number of the facets of their business. So this has a lot of gravity to it. And so I think we'll need to talk about all the steps that happen before you deploy and what the criteria are once you deploy. But for now, take it as a leap of faith. You're going to be at some point ready to deploy the model. And then another thing that happened in the naive early days of machine learning is we deploy the model and we thought we were done. That's absolutely not the case, because we need to keep an eye on that model and make sure its accuracy persists, and expect that actually it won't, that there will be drift in accuracy. There will be drifts in terms of how the data is structured, and all that work you did in the data exploration. Most of what you discovered will remain intact, but data changes. And as data changes, as the inputs change, as the business and the conditions change, it's going to be necessary to retrain the model. And that really starts the cycle all over again to a degree. It's iterative, so it's not like starting from scratch. But we need to see this as, as a cycle, the way we have it here on the screen. It's kind of a circular thing. Even if we've drawn it as a rectangle, that's basically what it is. So that's the whole progression, and I think it's important to kind of internalize that. And then what we do, sorry, before I keep yapping, Stefan, did you have any comments or questions there? Or you?
No, I think you hit the nail on the head, right? I think that a lot of the stuff on the maybe more right-hand side of our quadratic circle, so to say, yes,
Yeah.
it is an a Zen circle that basically continuously circles. I think a lot of the stuff, right, about the model training these days is a little bit wild west still. When we go into organizations, I think people struggle to hire machine learning talent. It's typically folks that are super smart, but also early in the career. And the exciting part is to train the model and test it, right? But the not so exciting part is to document the data lineage that was, used to do the feature engineering, to like really carefully have deployment strategies to really make sure the monitoring is set up in a way. So that's a few things that we will discuss in a minute. But overall, I think what we're seeing right now, it's Python spaghetti code a lot, right? As people just racing. And as ML-driven product capabilities or, business processes are becoming exciting and very dominant, we spent the last 20, 30 years to build really reliable data infrastructure. And now we're duct taping in some really mission critical stuff that, many times just one individual cooked up in the basement. So I think we see things continuously blowing up, and not just from a reliability perspective. A model can get easily overwhelmed, like where's the failover? Where's the load balancing, this and that. And then of course you get complexity if you go into LLMs, because you need to provide context to the LLMs. How do you do that all? Right. Long story short, I think we spend a lot of time building infrastructures that are appropriate, and now we rushing in some technologies that are not as enterprisey as we should put them in. So I think that's something we really need to look at. And then obviously
that's the push and pull of the industry. Actually, I'm glad you said that, because I don't know. I mean, machine learning has been very groundbreaking and very innovative. Typically, when you have something that's groundbreaking and innovative, there's not a lot of process around it, because there's so much discovery and pioneering going on. People don't want to kind of interrupt their their flow of thinking and discovery. So we go from like breakthroughs on the one hand to fit and finish on the other, right? And the more something becomes business critical, the more important the fit and finish is, or you get unintended consequences that come out of the shortcuts that you kind of take when something's still experimental. And machine learning for a long time has been experimental. The practices have been for data scientists to be doing stuff, writing Python code, running it on their own laptops, just to get a model until it feels good. But that, and then putting it in production, but that puts a whole black box around the whole process. It's the opposite of rigorous.
Yeah.
It's the opposite of, you know, you mentioned lineage is important. So too are the individual transformations that went into the feature engineering. But like, if you stop to write all of that down, maybe you don't get the breakthroughs. So we have to say, you know, the innovation kind of needs to happen on the side, and then as we bring it into production, it's got to get more formal. And now maybe it makes sense to go to the next slide and talk about some of the criteria and so forth that are important to make the process more formal. So what we talked about here, key criteria basically are the names for specific capabilities or features that we think are important in a category. And when I say feature, I don't mean machine learning model feature, I mean product feature. And evaluation metrics are meant to be the qualities that we need to look, that all of the products have the things listed under evaluation metrics, but to different degrees. But on the key criteria, obviously, since I mentioned how important monitoring is, we need to have advanced monitoring, not simply something that kind of logs all of the predictions and so forth that were made, but something that really keeps an eye on all the things that can drift the data, the accuracy, and so forth. For machine learning specifically, less so for LLMs, but even there it's important because there's so many different foundation models. It's important to keep training new models and then comparing the efficacy, the accuracy, and the efficiency of one model versus the other. And if you can automate that, then you can constantly be evaluating new models and putting new ones in production as you discover ones that are more accurate. You know, the demand on things goes up and down, so you need to be able to scale the serving of your models up and down. And retraining, we already mentioned how important that is. CI/CD, just like for code, where you want to keep compiling your code and testing it and then putting a new version in production. The very same thing is true of machine learning models. Machine learning models, I would argue, are a form of software development, even if we don't think of it that way. So all the rigors that we have in software development should apply here as well. And deployment, clearly, that's got to be something better than uploading a model file, you know, to a folder in cloud storage somewhere. It's got to be something that's measured and monitored and logged and so on and so forth. And the evaluation metrics, I think, kind of speak for themselves. Perhaps reproducibility and collaboration, I'll just speak to those really quickly. When you build a model and you run all the experiments to evaluate it and to look at its efficacy and accuracy, you need to be able to go back from scratch and reproduce the environment that was used to do that. You need that for audit purposes. You need that for just being, you know, kind of careful about understanding the process that went into it. And you may need to do it to recreate the model if for some reason the asset gets damaged or turns out to be slightly flawed. And the collaboration is all about different, not just different data scientists, but different people in different roles, data scientists, business analysts, stakeholders in the business, being able to communicate while model development is happening and after deployment has happened too. I think that more than covers what we have in the slide here. Go ahead.
Yeah, thank you, Andrew. So, and now with these things in mind, the foundation, thank you for laying them out, Andrew. I want to jump into really what is now external pressure here. So there is a tsunami of machine learning regulations really coming. Most dominantly, the European AI Act that was just put into law. The way to think about that is maybe a new GDPR. I think a lot of companies really struggle to implement GDPR. And GDPR was the first law that was a European law, but actually was applying globally, because the moment anybody would use your service as a European citizen, right? So me being German living in the US, every US company I interact with can be held accountable for GDPR, and the same thing will happen for the European AI Act. So it is a law that will be really applied globally, which is really interesting that these mechanisms are in place these days. And then folks really have to comply with it. But it's literally just the first one, right? There are so many other things that jumping in here, but the overall global, the governments, the regulators globally really trying to catch up with the AI development. So let's maybe look a little bit closer. What does it really mean? It is very serious. So, for example, for the European AI Act, failure to comply and put in these, regulations could be 30 million in fines or 7% of annual turnover, not even revenue or win turnover, whichever is higher. So the fines are extraordinarily high, right? If you a bank, and again, it's not revenue, it's not profit, 7% turnover, that very quickly could turn into billions in fines if you're a global bank, which is just absolutely extraordinary. But it is intentionally made so the politicians and the regulators that put this law into a law, these regulations into a law, really clearly and loudly communicated that they feel it needs to be extraordinarily painful to break it, so that people taking this very, very serious. So the way to think about the European AI Act is that depending on what they call a pyramid of risk, certain things have to happen, right? If there's a low and minimal risk, there are no obligations. It is to be discussed what that could be. So now, of course, the interpretation of the law is kicking in. But then things with limited risk, right? And this could be already really simple predictive model that maybe just simply suggesting autocomplete, right? Or generating emails or things like this. There needs to be at least a transparency. So which data went into this model to generate this email? So now we immediately have a problem, because if we're using, an open AI model, the data that went into training there isn't transparent. So now this is where open source model become really interesting, such as Llama 2, where it is transparent what data went in there. So it's immediately and a thing for companies to like pause here, because certain offering in the market, again, do not comply with this anymore. And again, these are kind of the currently widely adopted things. Then higher risk things. So, and this is already like, for example, models that help with underwriting, financial decision making, right? Because here we immediately could, of course, discriminate people. So here clearly there needs to be, or the risks need to be regulated. There needs to be fairness tests in place, things to really ensure that the model was trained with the appropriate distributed data, model explainability and so on. And then unacceptable risk. Here, this could be models where we do AI for law enforcement, for example. That's a topic, facial recognition, and certain things. But again, I think that immediately there is need for companies, even if they like, well, we're just doing some cool recommendation here. put the appropriate regulation and processes in places. In the US, in contrast, at this point, President Biden put in Order 13960. At this point, this only applies to vendors and technology that is used within the US government. Because that was, quote unquote, an easy way to quickly get something out, to be honest, right? Because it just could be an executive order. But basically, the idea here was to put in a foundation and really set the tone. Now, for example, California made a statement that they will adopt the foundational, elements of the order into California law, and we're expecting other states to do this as well. And then again, the way things work in the US, it just takes a while to get it to the appropriate processes to put something into place. So, but clearly here things are rushed as well. There's a few interesting elements in the executive order. For example, that the NIST, traditionally more an organization that sets standards, now defines kind of mechanisms and procedures to really making sure that like the appropriate risk assessment and processes are put in place. Andrew, I saw you coming off mute. Did you want to add something here?
Yeah, sorry, I was writing some notes down and my keyboard's kind of clicky, so I put myself on mute. But first of all, my other job, I have several jobs. One is I call myself a acronym police person. So GDPR, for those who don't know, is the General Data Protection Regulation. NIST, I think, is the National Institute of Standards. And I just wanted to mention, for those in the audience who aren't from the United States, an executive order is an interesting thing. It's not really a law. It's something declared and enacted unilaterally by the president and not by our Congress, which is the lawmaking legislative body. So, I'm just supporting what you're saying. This is meant to kind of put in a floor, kind of a very basic framework that likely legislation will build upon. And the last thing I wanted to add is that the competition between vendors in the AI space is so intense that a number of vendors have come out and actually said that they want the government to regulate what's happening in AI. So vendors kind of recognize that things are, to use the term you used, very Wild West, and that it ought not be. And it's really kind of a third party, i.e. the government, that is in a better position to specify, specific requirements and put down regulation that then can, just provide a framework for vendors to use as rules of engagement and to make sure things stay within good practices.
Thanks, Andrew. Two things I want to highlight here that are that people seem to be surprised when I talk about this. So red team testing is a requirement. So really having white hat hackers now that are trying to break your ML environment. So that's a part of the regulation, and we will see this in other laws as well. So, we have cybersecurity experts right now, but really making it a process trying to break your ML system is a thing. But here's another one that people seem to absolutely ignore. When we work, we at Automation Hero work with some of the biggest financial service organizations, and they're really rushing right now because what we see right now is the biggest data breaches that we saw in history in these companies, and it is discoverable. So here's what happened. You any kind of organization, it doesn't even matter if financial service or not, and you have, a sales rep, a customer support rep, whatever, who's like, you know what, my job's really hard. I will make this really easy. To answer this email from my customer, I just copy paste that into this cool ChatGPT chatbot and generate an answer. Well, what happened just now? someone copy pasted personal identifiable data into a public service that in a terms and conditions says everything you copy paste here can be used to retrain the model. And in fact, they do that. And in fact, they have thousands or tens of thousands of what they call human in the loop people. That's in fact what ChatGPT made it so great, is this paper about human in the loop reinforcement learning, to really then continue tuning the model. So millions, every day, millions of records of companies leaving the company by copy paste into these things. But now read the last bullet point. The regulation requires that any content that is created is watermarked. So anything that ChatGPT is creating, there are watermarks in it. The way the words are generated, the way commas are set, the way spaces potentially are set. It's not just about the generative images. Even text is watermarked, and there's plenty of research papers. What does that mean? That means me as a consumer, the moment OpenAI is adding this business model, what they rumor to add, that you have a little website where you copy paste text in and it tells you, yes, this was created with ChatGPT 3.5 or 4. You can say like, wait a minute, dear company, I got this email a year ago from you, and it contains some information that is protected by GDPR or what have you. And clearly it was generated by a generative model. So we have massive data breaches in companies right now because people are using generative AI left and right. They're using it by copy pasting personally identifiable data. And again, all the content that is created is watermarked, so it's discoverable in the future. So this will be massively a problem. And I think the quantity of companies is not aware that this is traceable by this watermarking. So anyhow, companies really quickly need to wake up to this. So
Can I also just mention, if you think back to that rectangular or cyclical diagram that we had, in the days of machine learning only, it was sort of obvious, this is data, I'm using this data to train the model and I need to be careful with it. In the days of LLM, everything is so much easier that it actually obfuscates some sensitive things going on. So you don't train LLMs, you tune them. And of course, you ask them questions. And as you have just discussed, the data used to tune them, especially with using retrieval augmented generation or RAG, when you want to provide some context for the model, that's sensitive. And as you were saying, so are the prompts. So if you think about the stuff we need to manage in machine learning operations, the sensitive stuff is obvious. In the world of LLMs, there's still sensitive stuff, but its sensitivity is a bit camouflaged. So it's important to kind of keep your eyes open and realize that things you do casually because LLMs make things so easy still requires scrutiny.
Yeah. So in the interest of time, the NIST framework really contains a few elements: map, measure, and manage. So really all around risk tracking, mitigation of risk, having an inventory of all your machine learning, which, by the way, then, of course, includes simple things such as OCR, because that's machine learning. Document everything around that, data lineage and monitoring of input, data and model. And then a key aspect, of course, is explainability and fairness, which we will get to in just a second. So here's a pyramid of really things you should do as an organization that uses in any kind of shape machine learning. And again, something simple as document processing can be part of that. You need to create an inventory of everything that is out there that is a machine learning asset. There needs to be lineage around everything. The lineage about how is that model created, the lineage around the data. You need telemetry from the training as well from the serving. You have to have policies in place. You need to have ways to detect threats, to hunt threats down, then to track if those were successful and then act. So the top of the pyramid, again, think of it maybe also almost like a SOC 2 compliance, where you have responsibilities, processes, things how you would, again, like deal with a data breach. So very similar things will have to be in place. So this will require you a lot of capabilities that you will have in a stack, in a tech stack. And again, I don't think that much of that is available if you just use a Python notebook, which seems to be the standard these days. So I very strongly recommend to, again, step back. The regulations are there now to really assess what the tech stack is, all the way from development to serving. But there's a bunch of things you will need, right? Obviously, some standard stuff, the model serving capability, but then again, the data lineage that needs to go all the way through, and not just over here, but also, again, already from the model development and serving, you know, the connectivity, the human in the loop, the red team testing, visualization, prompt management now for the LLMs, and what have you. So a lot of capabilities will be required. Now, as we rushing to deploy AI, now we have these regulations. How can we continue to move quickly, right? And again, this is where we would love to show a few things here today that we can offer. But as a summary, companies rushing to deploy AI, but regulators stepped in. We need to immediately really understand the regulation and implement them, because anything that you're doing today that isn't comply with this regulation, you will have to redo. I want to be really clear. Every model you're building today that isn't confirmed, you will have to rebuild, and there will be millions of dollars spent on redoing a lot of stuff because you didn't follow the guidelines, the rules, you didn't have the tech stack in place, and so on, which will be very, very painful for a lot of companies, and especially for the smaller companies, it sometimes will be prohibitive, right? And that means you're not compliant. So anyhow, it is about risk mitigation. There's clear guardrails here now. It is an opportunity to really put things into place right now and be clean. But this needs to be something that needs to be discussed on the C-level. So strongly recommend to make this a topic. Obviously, it's more the technical folks that know all the AI stuff that's going on, but the C-level folks need to be aware of the regulation needs to put in place. So with that, I would love to spend a few minutes on talking about what we're offering to mitigate these requirements. So maybe a quick introduction. Here we at Automation Hero, we build platforms such as Hadoop, Spark, HBase, Kafka, what have you. So we have a lot of big data background. And again, our last company processed 80% of financial records in the US. So we do understand what some of these requirements are. So we built a new AI OS really under the hood, and then we on top build an automation user experience, and on top of that we added a lot of machine learning, prepackaged machine learning models around document understanding. But really what you have under the hood here is a data platform that scales up to 1,000 servers that can run streams, batch processing, or run as a microservice, and really makes it really simple to deploy machine learning use cases, very simple. We don't do the model development, but really moving things into production, right? And again, we have some of the, well, we do have the best, we now won twice the GigaOm radar for intelligent document processing. We do have the best AI models around handwriting, understanding tables, forgery detection was a document, Photoshop, signature detection, the whole shenanigans to really process complex business processes that are document-centric, underwriting, claims processing, contract management, cash flow optimization, these kind of things, right? So again, this is kind of on top of our pyramid. But now we would love to introduce to you our new AI governance framework that we put in place to really protect folks from these regulations. So we're really proud of what we put together there, if I may say so. I filed a bunch of patents around that because we feel, again, it is important but we found a really interesting approach to it that really protects folks. We actually built a whole stack on top of cryptocurrency technology, so specifically a blockchain for audit logging, and then smart contracts. So smart contracts is basically code that runs in a blockchain autonomously, and once deployed, again, it is guaranteed to be executed. And we're using that under the hood to ensure machine learning policies that you defined are really executed. So here again, you have the protection. You know, it's not a text log file that said, oh, I followed these regulatory steps that we defined in the company, but there's a crypto-based audit log that, you know, can't be manipulated for your protection. So with that, maybe I just want to show some of the capabilities, and then I know there's a bunch of questions we can jump into that. So want to just quickly give an overview of the platform itself. So this is our platform, and the way you build flows here is really just track and dropping any kind of data in here. And again, you immediately have the lineage here. Now you can do your feature engineering to build this, right? Combine it even with some business logic, wire things up. But the key again here is that you have immediate data lineage. So at any point you can understand how data is flowing through. This, of course, can be exported for regulatory requirements. And then you build almost your intelligent apps here, where you have, okay, here have a classification model, and here have an extraction model, and everything again can be tracked. You have the collaboration capabilities, everything is versioned, and then you can put these flows and you know, run them continuously as a stream or as a batch at certain days, or, you know, what have you, every few seconds and so on. So we introducing, oh, of course, now I need to relog in, my apologies. We introducing now a whole governance framework around that. So the first step here is to define policies. You can now define policies for your machine learning models where you clearly define, okay, here's the life cycle stages. I have my development, I have my testing, I have my QA step, I have my production step, I have my archiving step. And then you define in each of these steps certain data requirements. Okay, in test and development, I can only use data that is tagged as test and development. I can't use data that is tagged production, personally identifiable. I have to maybe not pass in the development and testing frame certain fairness and explainability tests that are required. But in the production stage, you know, I maybe can not have more than 5% data drift. We talked about that topic before. Or I need to pass certain fairness assessment tests. So you can define all of this in different policies. And then you can associate, of course, your models with these policies and approve the life cycle steps and so on. And here, as an example, we're pulling in a popular machine learning model, actually from Kaggle. And just to give you a feeling, there's 350,000 and growing quickly machine learning model on Hugging Face these days. And we're seeing companies left and right, oh, let's use this Hugging Face model. But you immediately are exposed to the regulations, even though maybe the open source developer wasn't exposed to the regulations. Now that you're using it, applying to your customer, you are exposed. This specific model here is a model for predicting if someone will default on their car loan in India. And again, it's open source, so it is used by maybe financial organization in the region. So let's look at a few things here. So of course, we have a model registry here. You upload the model, and I will, in the interest of time, skip that with your training, reference, holdout data set, and so on. And that basically allows us to create what is called a model scorecard. So we immediately now can use not just the existing trainings data, but actually be using generative AI to create synthetic data on top of that to measure how is this model really impacted by attributes here. So what are the top attributes? And you can see that a whole bunch of attributes really have no impact on the predictions. But then there's a few ATAR flag, voter ID, pen, and so on that for this model seems to be really relevant. And you will see in a moment, it looks like a cool model outside to predict car loan defaults, but it's immediately discriminating. So next thing we have is Mosaic report that I really would like to highlight, which is something really interesting. So for example, we're working with life insurance. A life insurance, of course, is prohibited and using gender to predict maybe if you underwrite a person or not and to which condition. However, in the US, health history is used to predict that. Well, if in your health history was a pregnancy at some point, you infer basically a gender. And this is an obvious example with pregnancy and gender, but there are things that might be not obvious immediately, especially again, if you have like the junior data scientist that again has a PhD and so on, but maybe doesn't know your business and the data and he's just throwing it all in. So here, for example, we see that there's a relationship between voter ID flag and a TAR flag. And me being a German, I didn't know what a TAR flag is, but FYI, this is if you have an Indian passport, that's your passport ID. And as you remember here, oh, okay, well, these were really relevant attributes. So now we have a bunch of course, other kind of standard performance metrics. I want to jump over them because I don't want to bore people. I really want to highlight the fairness test. Again, this is regulatory required now. And it is really critical. Every other technology out there right now will require you to define which attributes potentially encode discriminatory values, which again might be not immediately clear. So we cracked the nut here. Again, we're using all sorts of generative AI capabilities in the backend to really identify some of these or identify which attributes potentially are discriminating. So here the AI under the hood, without having no knowledge about the AI model, basically treating it as a black flag, a black box, and just getting kind of, okay, here's the attributes that are coming in and here's some training and holdout data and what have you. And our platform under the hood identified, again, without having any knowledge about that the ATAR flag is actually 92% correlated with race, which makes sense. If you have an Indian passport, it's likely you Indian, not Pakistani, for example, or a British or German or what have you, right? So clearly there's a relationship there. And now that we identified that this attribute is impacting a protected class, let's look if actually minorities are discriminated. So here on the right-hand side, what you see in the middle, you have your majority in your production and trainings data, right? The people that actually do have an Indian passport. And then look at this. The people that don't are actually 26% more likely being flagged as defaulting for the loan, just purely based on that attribute. And again, behind the scenes, we did all sorts of synthetic data and this and that to identify that. So clearly, this model is highly discriminating based on race. And again, if you just go and use this model, it seems like, oh, cool, it spits out predictions and yeah, maybe I cross-validated and it seems to be like clear. But again, under the hood, this would not pass any regulation requirements. And this is just an example. There's, of course, more here, but in the interest of time, maybe I show just one more thing. Now that you have an understanding of the model and you're putting it into production, you need to monitor what Andrew also said. Here's a capabilities and the platform now to monitor your model. But one key area is I want to highlight again, we talked about drifting. So what is drifting? Well, you maybe trained your model mostly, let's say something simple, on men 30 and younger, and now you apply it to women 30 and older. Well, you clearly have a drift here because the training data is very different than your product data. And I apologize for that really simple example. Obviously, it could be more complicated, but here you can actually see this indicates how much the data, and these are your attributes, per execution differentiate from basically your baseline data, right? So it is an indication for you to understand how much the data is drifting off. And if we just look at this in detail, now we can, in this case, here we can look through how the data, this is a histogram representation, again, it changed over a period of time. So it's kind of like just a neat way to look at things, but you will find this being incredible important as you're trying to debug, why is my model going off? And again, there's all sorts of other things. And then finally, you have your ledger. And this is the most critical piece. Of course, it's the least visual pleasing, but here now again, in a cryptocurrency technology way, there's a ledger that can be manipulated, which will hold up in any case. And maybe you remember that one of the very big banks recently was sued by hundreds of millions because a credit card seemed to discriminate based on gender. So now you have an opportunity to say like, well, we have the policy, we did the fairness test, we did this. So this will definitely protect you from that exposure. And FYI for the techies, this is of course a private blockchain, so this isn't necessarily going into the ether, you're running your own. But again, think of this as like a really cool e-signature kind of approach that again can't be manipulated. With that, I want to pause and see, and just Andrew bring you back and answer all sorts of questions. But maybe
I'm chomping at the bit here. There were a couple of things I wanted to say. One is that when regulations are new, people don't understand, and I don't mean people who are naive, I mean everyone. They don't understand the full ramifications. Even the people who wrote the legislation or wrote the regulations don't understand the full ramifications. You've got to be defensive. You've got to sort of say, all right, I may not know kind of what facet of what I'm doing will be audited, but I know I'm going to be held responsible for it. So you really need a pretty big safety net, and what you have built provides that. What Automation Hero has provides that, because there's just a whole kind of range, a whole horizon of possibilities of things that might be asked or might need to be documented. And I see you guys taking a really cautious approach to that and saying, let's err on the side of capturing pretty much everything, not just what happened, but also intent. And intent's going to be a big part of this. Sometimes when regulations new, what's the most important thing is that the parties made honest efforts to be compliant as far as they understood what compliance was. And again, I feel like what you've built with Automation Hero is providing for that. The other thing I wanted to mention is that there are so many pieces of technology that have been siloed in the last, 10 or 15 years. I wrote some of them down here: data integration, data analytics, machine learning, process automation, policy, deployment, monitoring, and audit. These have all kind of been looked at as separate things that then have to be integrated and stitched together. And Automation Hero actually has all of them, and not just that it bundles all of them under the same umbrella, but the way you showed the flows, it's all tied together. It's all naturally part and parcel to the same thing, which I think you're so used to it that you're kind of modest in not pointing that out. But I think it's huge, right? Most solutions just don't have that wide a scope. And if they do, then they're all over the place and they're not focused. Somehow you've done both.
Yeah, and you can't, then you have to integrate them, which is almost impossible. And then you start taping, and this is where things breaking down. In a world where we will have really critical infrastructure being machine learning driven, everything is written in Python, which you can override during runtime with code. The cybersecurity implications are huge, right? Thanks for the flowers, Andrew. One thing I forgot to demo and show is folks, we do have the generative AI capabilities here plugged in as well, with private generative models that actually, in fact, for, you mentioned earlier, retrieval augmented generation, RAG outperforms kind of the public offerings, OpenAI, because we have some cool retrieval tricks up the sleeves. So all of that is in there. So you can build your generative AI use cases. Again, it might be RAG, might be email automation or customer response and so on in a private environment without calling someone, which is interesting. Most of the vendors out there, hey, we have generative AI, and they're calling, you know, an OpenAI API, where, as we discussed earlier, it's totally inappropriate. I mean, it makes a cool demo for a second, but then given regulation is just a no. Yeah, everything you just saw, basically, you can plug in an open source LLM to like a Llama 2 or something and be completely regulated as well. Monique, I think did we have some questions we can answer?
Yeah, gentlemen, I just want to say thank you guys so much for going through that. We have a number of questions that came through, so I'm going to try to pick and choose which ones I think might be the most relevant to the audience. If we don't get to yours, we will reach out separately with a response. And I just put in the chat that you can also email us at hi@automationhero.ai. I think this is pretty relevant, and we talked about it kind of roundabout, but maybe just to pull it all together, specifically around customer data. What is Automation Hero doing to protect customer data and ensuring that, you know, PII isn't being released? What kind of on the back end is happening, and how does that look for people who are working with our platform directly?
Yeah, I mean, so many things, but net is, so we, for example, don't store data. We think of us as more of a data fabric technically. So we connect to, you know, your data lake, your data lakehouse, your database, your streaming service, what have you. And then as the data flows to the platform, of course, everything is encrypted during transport. You know, if there's data cached, then it's encrypted at rest. And then you have rule-based security, then you have data lineage, and basically you have what we talked about before, right? You have the stack of capabilities here that can ensure that certain data can only be seen by certain people. So all of that is in a platform and can be easily clicked together.
This is going to be kind of a loaded question for Andrew. I'm going to try to combine some questions. You know, we've talked about ML ops and dev ops and LLM ops. How do you kind of see the differentiation between those three categories and then the overlap? I think there's maybe a little bit of confusion of how those markets are kind of developing.
Yeah, and you know, the first edition of this report that we did, ML ops, was, you know, as happens often early in a technology process, it was starting off as its own product category. So we had startups that were focused just on ML ops. And there's still some of those, although a lot of them have been acquired by now. And that's really because ML ops needs to be built in to, you know, larger, more sophisticated platforms. And so the idea of having it standalone, which just fragments a technology stack even further, is a little dicey. So ML ops is finding its way into AI platforms. It's finding its way into DevOps platforms, because if you're already doing DevOps, then you shouldn't be duplicating all your DevOps with specialized ML ops that ought to be coordinated. And LLM and generative AI is kind of putting another generational spin on this, and no pun on generation. And so we've got to be careful there too. But as I said, you know, in the world of LLM stuff, instead of worrying about building and training, you're instead worrying about discovering and tuning. And instead of feature engineering, you're looking at prompt engineering. And instead of training, you're looking at tuning, and so on and so forth. But really, we ought to be careful not to differentiate everything and say it's all separate and it's all a different category. We should look at the commonalities and then make sure things are overlaid and that one becomes a superset of the other. Did that answer the question?
Yeah, I think there's a lot of information in there. And I'm thinking we will provide a link to the report if people want to take a closer look in our follow-up email. It's pretty comprehensive, and you can purchase rights to review and license. So we'll follow up with that. I think we have time for one more. I'm going to go with, let's talk about retraining, why it's important, and if there's any ethics implications, and what's the deal with continuous retraining? Is that something, is it kind of one and done, or how does that live and learn?
Yeah. So
That's for
as
both
I
of you.
was, yeah, that's for me or for
Go
for
for
you,
it. Yeah.
Stefan. Okay. I mean, I think in the naive days, data scientists were building models on their laptops and then putting them out there on a server or in the cloud, and all done. But that's ethically and operationally and regulation wise, that's not only irresponsible, but it's also quite dangerous, to your own well-being as a company. So I mean, Stefan showed that amazing 3D visualization, and that wonderful mosaic where you could kind of see everything at a glance and see how things are drifting. Things drift. That is the nature of data. That's because ultimately data are just point in time recordings of things that happen in the world and things that humans do. Those are not constant. They change. And so those have to be monitored. If they're not monitored, you're not being vigilant. If you're not being vigilant, you're probably not being compliant. And so what that means is when you pass a certain threshold, you need to retrain your model, or you need to retune it if it's an LLM, or if you're an OpenAI or a Meta, maybe you actually have to retrain the foundation model. Life is not static, which means data is not static, which means that the criteria for what makes a fair model is not static either. It all has to be observed, and it all has to be managed proactively. And that's very different from the kind of magician approach to machine learning, which is like a magician never tells you the secrets to their tricks. The magician actually shouldn't be a magician. It should be an advocate, and that advocate needs to share what they did to build the model. And that is it's antithetical to the way things have been. So now we have to actively change our mindset.
I think that's an excellent point. And also, it's relearning best practices for your organization and really building that into the culture mindset. And we've seen that when Center of Excellences were first being built, and how that has to now be brought in. So it's going to be a bit of a learning hurdle, I think. So
when things go from specialized to ubiquitous, all the criteria change in terms of how you manage it. And that's where we are now. AI has been like I don't know, like just a nerdy thing for decades, and now it's mainstream.
Yep.
Excellent point. Andrew, Stefan, thank you both so much for your time. Everyone, thank you so much for joining us. I hope you guys learned as much as I did. And hey, again, don't hesitate to reach out, and we hope to see you guys again soon. Everyone have a great rest of your day, and happy holidays and best in 2024.
Thank you so much.
Holidays.
Take care.
Andrew.
Bye.
Bye.